Hello everybody and welcome to this tutorial how to take a work table like this and then under the work surface create a nice and beautiful sheet metal basket like that. And then of course we will make a copy of that basket, move it away, and guess what? Correct, we are going to unfold it. I'm going to show you in this process video a fairly easy to set up and actually surprisingly well working manual method how to calculate how we have to unroll this geometry into a flat pattern. So we can then take this flat pattern and load it into the drawing. So we can send this out to a metal shop to create a physical representation of this digital design. And all that, of course, in Shapr3D. As always, all the files are being shared with you, so please go ahead, download those, and we will start with a simplified version. So here we have now the simplified model. As you can see, this is just only the table without the basket, and all the sketches are gone. So this is a nice and clean design to work with. The unit system is in inches. This design was made in inches, so it makes sense to remain in that unit system. I will turn on all my snapping elements, and we would like to start by going to the right view, center our table, and then we turn on the section view, because now I can see through the table. I would like to have the metal basket on the left side, being flush under the table surface and running along actually this metal frame that sits under the work surface. Somewhere I start drawing a few lines like this. I can select these 3 lines, make them horizontal, vertical. They all should be 4 inches. I can select them all together, say equal, and at 1, I will say this should be 4 inches at this dimension. Now I can bring this into a position. And if you take a look at the geometry of my cut section of the table, you notice that after we started drawing our first line, we started getting these interesting magenta points. These are snap targets, where actually the sketch intersects with the geometry. And there I can snap to this point. Perfect. Easy positioning. 1 line to the left, 1 inch. Very good. 1 line to the right. Both lines horizontal and vertical, and both lines being equal. Very good. Perfect. So now we have actually the position of our first sketch created. And this sketch defines kind of like the inside surface. So we need to create the material thickness. And for this exercise, we try to work with pretty thin metal. So we go to Edge, select all 4 lines. There we are. And then we extrude this out by 0.04 inches. Really thin. Come back to line, and then we close actually this. And there. Beautiful. By having this sketch actually now closed, what I can do is when I go into a 3D view and turn off the section view, look from below, can zoom in, select the sketch profile. There we are. And then extrude the amount of metal out I would like to have. Here this would start hitting actually the metal frame. So let's say this should be 26. Very good. Let's do the opposite side. I select here the face of the basket. So 26 multiplied by 2, that's 40, 52. I just enter the number. Beautiful. Yeah. So there we have actually the basic basket, but it's solid. I need to have openings. With the openings, because this is also folded, we want to make it from the back nice and stable and from the front nice and accessible. So before we continue, let's actually make sure that our metal basket and the sketch all is outside the bodies folder. And it is. Okay. This here is my outside face. I will select it with the pencil, with the finger, double tap. Can zoom onto it. If I want to turn on section view, then I can look through it. And now I can do the following. How much is this? This is 1 inch. Okay. So I will draw here a line 2 inches in. And you see that this lines up with the left edge. Then I can bring this down, bring this over, bring this up, 2 inches over, bring this down. Very good. Bring this over, bring this up, and 1 inch, 2 inches. This should be. These three I can all say equal. Very good. This point here I do not want to move, so I will lock it. These two lines I will make tangents, so they are at the same height. Or not necessarily height, but at the same level. And now this point I will move over, and before I do this, let's actually undo the step. Select everything and make sure they have horizontal, vertical constraints. Now when I bring this over, this deforms correctly. Also here, because again, I work with nice clean inches and I model along the grid, I don't need to project an edge from here into the sketch. I can simply use the grid and align this perfectly. Like this. This is good. So when the 3 top lines are 2 inches, it's actually defined. I can select these 2 lines down here and simply say, make those equal. And by doing this, as you can see, beautifully, it's centered actually, everything. That's a really effective and nice sketching trick. So this is done. That is actually really good. The last thing I will do is I will add a line here and a line there. Main reason for that is I will turn cut section off. I will turn this body off. And then I will select these 2 faces, extrude them out a little bit, and push them over to there. So this is actually much wider and runs through the basket, as you can see. Very good. Now, let's give objects a name. We call this sheet metal basket raw. Very nice. Okay, so from this piece, I would like these 2 objects to be removed. So we can go subtract, keep bodies, and actually keep originals all, and click done. So here are my 2 elements that did the cut. Here is the raw piece, and there is actually the piece where we cut everything from. And we can change the name simply to sheet metal basket. Very good. Okay, nice. All these elements here I will select and put for the moment into a different folder. Just call this sheet metal or however you would like. So again, this is the outside and then this is the inside. And now this is a design question. How many of these vertical posts do I really need? It's also pretty thick material. Maybe what I will do is I will select this face and extrude and clean up the center part. So from the inside, I have a much nicer and bigger open area, easier to access. Very good. Yeah, that looks pretty good. Okay, so what's the next step? We can actually add few roundings. When this has a material thickness of 0.04, let's do the rounding then here too, .04. So we make a small crease, not too big. Let's do the same here, 0.04. And then that means that this one is 0.08. That's the inside radius plus the material thickness. Okay, very nice. Do we like this? Let's see. We make this 0.08, a little bit bigger. Then this would be 0.12. Maybe this looks nicer. Keep in mind this is metal, and we can actually bend this not necessarily around a super sharp corner. Oh, we can, but then it's very sharp. We want this to be soft. So then, because we did this at one position, we have to do this also on all these other positions here. 0.08, there we are for the inside. Same here. I try to work in tandem, meaning I work on off edges that use the same value, and now I'm going to round these edges which will have the bigger value. Very good. Okay. This is a little bit of a cleanup and styling, particularly with metal here. Sharp corners are not necessarily that good. We will round those a little bit. So you see, 3D modeling actually, sheet metal is quite fun and easy. It's very step by step. Let's give this an inch of a rounding. This is too big, half an inch. That's the beauty of 3D modeling in Shapr with the direct modeling kernel. We can adjust everything so easily. Very good. Okay, so this piece nearly is done. Now we need to figure out also how do we mount this. We have all these faces, and on these faces we can create a sketch. So I select this face with a finger double tap, and because this is a rectangle, it finds actually the center point. Go to circle and add a nice big rounding. So here the question now is, how big do I make this hole? Now, this is a big tip because we're dealing with sheet metal, which has a little bit of, well, it bends on its own. It's not razor sharp like a block of steel out of which we mill with a CNC a very precise shape. So we want to build in a little bit of a tolerance. So 0.16 of an inch is actually not too bad. We can make this a little bit bigger. 0.19, or let's go with a clean value there. A little bit bigger. So obviously the screw that will go through it is smaller, but this gives us a little bit of a wiggle room. Okay, so here now we can go ahead and do the same. There we are. All these rings, by the way, I can lock, so I can't really change the position. There we are. And to make designing nice and easy, I set them all to be equal. Very good. Then here and there, lock, lock, and then these two, I can go to here and also say equal. So when I make this 0.1, you see they all update too. Pretty nice, no? What about 0.25? That is definitely too big. Okay. So this should be enough material to actually hold this basket right under it. This is a little bit wider on the side. Here, this is actually pretty good. We could extend this if we want. This is up to you. Because only because we made one sketch doesn't mean that we are stuck to it. We could move this further out. But I leave this where it is. This feels pretty good. Okay, so with these circles, we can select them. And as you see, select the fill with the pencil, push down, and I extrude through the sheet metal and cut the holes. So easy. It's really nice. And then here, the sketch, I can call sheet metal holes and put this one into there. Very nice. By the way, here's a little tip. Because I have actually these sketches, I can also find the positions under my work table now and do holes right into there too. Now this is not a very thick work table. So ideally I want to have some sort of a socket where I can put a bigger screw and thread it into it. But I think this is actually very good to know that I don't need to find new positions. If I would like to have a smaller hole, I could simply in this sketch create a new and smaller ring, maybe for a drill hole. And then this one I select and cut into my work surface. So it's kind of like one stone catches two birds. Sorry, birds. I love you. Okay, very good. So what else can we do now? The sheet metal basket is basically done. And I mentioned that I will show you a manual way how to unfold now this construction into a pretty precise format so that we can put this into your drawing. This design I will select, double tap and make a copy and move it somewhere else. And then I bring this one to there. Very good. Very nice. So the task I have now is I need to figure out how do I have to unfold it. And when I unfold it, I will have flat surfaces. That is very good, like here. And I need to figure out where is actually the crease. So where there is the midpoint over where I'm going to bend something. And what's the bend allowance? Now, for example, here, bend allowance. So everybody who's familiar with sheet metal will understand what this means. And there are methods to calculate it, but because this is such a thin material, you could, but honestly, once we actually take sheet metal and start cutting and stamping it, it won't be like that super precise anyway. So this process, which I'm going to show you right now, is totally perfect. And it doesn't require actually any higher math, no formula. So what we will do first is I will select this one more time and I make myself a copy right at the same position there. And then I will select here all these edges there and the same here. Go to offset edge and offset this by 0.02. So half the material thickness. That's kind of like the center line. And what is really useful about this trick is, here now I have actually the length of one piece. Here I have the length of the next piece. And this piece here in between is actually kind of like the length, well, of the sheet metal that is in between the two flat areas. Here the metal will be compressed and here the metal will be stretched. And the trick is that now this piece needs to be kind of as long plus this radius, or half of this radius on each side. And that actually is really it. So before we continue, however, I need to remove all these carefully crafted roundings we did here. And this goes pretty fast. And there we are. Let's go to here and there. And the last one. Very nice. And here. So, perfect. Okay, good. In the next step, we are now going to unfold this whole design, and then we need to reposition some of the edges. To unfold it, we can start, for example, here. I will select all the important edges, so the top, the bottom, the circle, and actually this endpoint. Then I can select this edge and bring this over 90 degrees. Very good. Let's do this one more time. There, inner edge, and 90 degrees. Beautiful. If you do not select actually this set of faces, let me show you what happens when we select only this. So there you can see we are rotating these faces, but the rest of the geometry, so the hole being cut, remains in place and adjusts. No? So that's the reason why it's important to select all those faces. Then in the secondary step, we have now to unfold this whole piece. Also here, this face I need to select. The fillets, they're probably not really, they will actually move with it. We don't have to really select really everything, just the important faces which could deform. And now to figure out what actually we have to select, you will see once you rotate something and then it does not rotate or unfold the way how you expect. So what about this? Yep, this actually works really good. Beautiful. There we are. So this was actually part one. Let me very quickly do the other side. It's actually a very good practice. There we are. And now this one. Oh, be careful with how you select your pieces. This should be 90. There we are. And then we select everything here one more time. Go to here, select everything there, including this face too, again. And you see me zooming in and zooming out a lot. That actually is a very useful process. So when you select something with the pencil, not by accident, you select something you do not want to. Oh, so there actually I got an error warning. That means somewhere, by the way, I did, yep, there, not select everything correctly. There. Very good. So we have actually now the piece flat. And now we need to figure out how do we have to reposition some of these edges, and what does actually edges mean? You see, when I zoom in and I turned on the show hidden edges, here's some of these edges, they are not at the same position. And because this is sheet metal, materials being stretched and compressed, this will grow along here and here just a little bit. And we'll show you now how we can do this. And to do this now, we will go back and take a look at our sketch here one more time. So this tells me this is 3 inches and 84. And then here, this arc has a length of 0.157 inches. Okay, good. So how ideally do we do this now? I will select this face because it's going to be the easiest one with a finger double tap. Then I zoom in a little bit. And then here you see there's a midpoint. I draw a line there. There we are. And then I can actually find the midpoint. And from here now I draw a line. There I draw a line. These two pieces I make equal. And what I will do now is I will select this line. 3.84 inches. Very good. So from there to there, 3.84 inches. You please stay horizontal. So I might have to move you back. There. Very good. Okay. And then when I zoom onto here, select this arc, the length of this arc is 0.157. So that divided by 2, 7.535. So we go to here, add a line. And make this horizontal vertical. I have to verify this number one more time. So this will be 0.07535. 0.07535. Okay, very good. Or as you see how it rounds it, let's simply call this 0.075. Very good. Okay, so we will do the same here. Another line, 0.075. Vertical, horizontal. Another line. Same length, by the way. And this is actually now my bend allowance. Very good. Another line. Horizontal. How long is this line? 3.8 inches. Very good. You see this actually kind of like the same. So .8. There we are. And then we have one more bend on top. So we will do one line and another line. We make those horizontal, select both, And I will select the line here with the dimension and make this equal. Very good. And then we have to add the last piece, 0.88. Very nice. I will do a very quick process. So you and you are equal. Very good. Then another line, another two pieces in there. I know actually 0.88. All those will be horizontal, vertical. These two elements here, U and U, to this one and be equal. There we are. Here is actually now the small piece that is left. That's actually the longer piece, which would be this one, the 3.8. Very good. So you saw a little sketching shortcut by using the constraint system. Okay, very nice. So there we are. Why did I actually do this design? So one more verification, 3.8, that is correct. Then this is actually 0.88. Let's select all this there and here and there. Very good. And there, and that is 13.82. Pretty close. Okay, very nice. So now what I will do is, this sketch is a little bit confusing, so I will remove it. I will come back to this view here. I have to do the following now. I will draw myself a line, and I always draw actually here a line from a sketch point. This way I continue drawing actually on the sketch. These three lines here I make horizontal. Then this line I will continue pulling down. There and there and there. There we are. Go to here. I'm going to create myself a nice sketch overlay so I can see where all my surface or solid edges actually have to be. There we are. And now I can select this line and nicely drag it over to here. So I have a perfect, beautiful overlay. Very good. So now actually I have the pleasure that I can make sure I have show hidden edges turned on. And all I need to do now is, so let's start from the center. So this is the edge here on top. That one is visible. And when I say visible, visible actually in the drawing. I go to here and I could measure what's the distance to here. So from there, so there to there, what is really the kind of like the distance? 0.005. So that means if I want to, I can select this edge, go to move, minus 0.005. Okay, so that one snapped perfectly. And then here to there, what's the distance? Okay, no, will be the same, .005, just the opposite direction. This edge is actually on the bottom. I can do the same precise work, or if I want, well, I don't actually necessarily need to, but I can just zoom in and try to align this so it's a little bit under there. Can also turn off the grid snapping so I can move this a little bit more freely. There I'm selecting this edge. And we have nothing selected there. And bring this to the center. There. Very good. So now for the sheet metal, I actually have this face prepared with a correct allowance band there. So the next step, this is actually more where we have to be careful in this design, if we really want to, because we're talking here about tolerance. So you see where I need to move everything to. This outer face I can select and then use more and translate and push this to there. Okay, so now we have the correct length. It's actually with the face super easy to do. There. Now, the thing that's important is we need to figure out when we made this little bit shorter. Essentially, we move the edge in. We also have to move then this circle actually in. So I will do an undo and I will calculate here what is this distance. 0.02. Okay, very good. Let's reposition this. So that means this opening, and this opening. If I want to be very precise, I simply have to move to the right side minus .002. Okay, so that was a very small movement, if you want to be that precise. We can also select this face, this face, this face, not this edge, and here, and do a move to. The 3D widget is somewhere here, so I can move this widget closer to here, minus .002. Minus .02. I guess I was wrong there. Okay. Very good. So that means here I made a little bit of a mistake. Oops. So .002. There we are. Fortunately, this is very easy to fix. Minus .02. And then here the same. We select this one. I could do math by calculating this, or simply move this back and then move this correctly. There. And one more here. And back. There. Beautiful. So the only step left now to do is correcting these edges here. So here in this case we have .025. Okay, so you will go down minus .025. Very good. Probably here the same. Correct. I will go to the opposite side. You see, when you fold or unfold everything exactly the same way, then even while this is a little bit of labor work, we can take very nice shortcuts. There we are. Here's the last one. Very good. -0.025. Beautiful. And if we want to work really clean, this is the face in the back. Looks like 0.016. And simply move this back edge, sorry. This edge might not necessarily really show up in the sheet metal when we take a look at it without having the show hidden edges turned on. So this task I'm doing here right now is actually not necessarily needed. I simply do this to create a model that is a little bit cleaner. Only the edges which are visible to the front are important. Okay, very good. There's actually our unfolded sheet metal. Now, this is ready to be put into the drawing module. To bring this into a sheet metal, we go to Add, Drawing, select the body, Next, and then we can give this a name, sheet metal basket. You select your paper format, etc. Continue. And I would like to add a view. Top is actually the best. Scale. Let's see what can fit onto the paper. That's pretty good. Then we can close this. Go to geometries. We can add center marks. Right at where we have drill holes, for example. There we are. Basic dimensions. How wide is the piece? How deep is it? These small parts, actually, what is their dimension? And this one. And try to make drawings, as a tip, not to be very confusing for those who are not very familiar with it. Try to make the drawings easy to read. And when you have somewhere something dimensioned, you don't need to dimension it again somewhere else. So this whole piece, for example, dimensions all those elements. I could also specify what is actually this material thickness. For example, here. There we are. And from here to here, what is this distance? Could bring this a little bit closer so I can easily read this. Very nice. Here, how wide is this? And there. If I want, I could add those. Same here. And let's do this there. We could also simply say they're all exactly the same, so we only dimension one piece one time. Very good. Last piece of element, maybe a radius, diameter, or the position of this to here, and the position from here to a side. So we identify the center of this. Maybe I'll bring this to there, and then the 44 I bring down. Very good. Okay. And that basically sums up this process of how you can 3D model a sheet metal basket, unfold it, and then via taking the measurement of the center, figure out how long pieces have to be, then unfold it, we correct it a little bit. So we can then create a nice drawing like you see here. That's it.